Dear students, welcome to the e-learning. Hello, I am Navdeep, working as PGDIP in Cambridge International School, Thrissur. Students, in the earlier lectures we have covered a number of topics related to basics of Python and then later on with the NumPy. Clear? So today we will start and work on database concepts. So our topic of the day is database concepts. So today we will discuss a few terminologies related to database. Here in the picture you can see that database, DBMS and all these important terms. So these are related to the different database topics. So moving next. Students, here you can see the overall view of our syllabus. And here you can see that the topic number 1 is Introduction to Computer System and it carries weightage of 5 marks. Then the Introduction to Python, that its weightage is 25 marks in the syllabus. Then we worked with the data handling using NumPy, its weightage is 15 marks. So today we are going to start the unit number 4 is database concepts. So students, till date we have covered the basics. As and when needed we will go into the details of the topics also. So here you can broadly see the weightage of the different topics in your syllabus, and also you can see the practical. The practical carries 30 marks weightage in the final exam, and unit 5 is introduction to the emerging trends in IT. So this is the overall view of our syllabus. So moving to the next part, the topics covered. So till date in the last couple of weeks we have focused on introduction to NumPy. What is NumPy? Numerical Python. We covered in detail that it is an important part of this important package of Python. Then we covered indexing. Then when we want to select a particular element or whole of the list or all the elements of the array, or like this. Slicing means selecting a part of the array. So that is what we meant by term slicing. Then we applied different arithmetic operations on arrays, like how we can add to arrays, multiply, divide. So then applying the operation row wise and column wise. Then we covered an important topic is transpose, how to convert rows into columns and columns into rows in two-dimensional arrays. Then sorting the arrays in the ascending order or descending order. Then concatenating different arrays. Clear? So what is the condition for concatenating means if we are adding two arrays, so their number of rows, if we are adding row wise, so number of rows should match. If we are operating column wise, so their number of columns in the both the arrays should be same. And finally we applied with the reshaping, that is how we can reshape. If we have 12 elements in a one-dimensional array, we can make it a two-dimensional with order 2 by 6 or order 3 by 4 in two-dimensional arrays. So this is we can reshape the arrays also. We cannot increase or decrease the number of elements in an array, but we can reshape it, okay, in different orders of matrix. Now students, moving to our today's topic. So that is DBMS. What is DBMS? Very important part, and I know no organization can survive without a database. So it's very important to go through the basics of database management system first. So here you see the definition of a database management system. So DBMS, or a database system in short, is a software that can be used to create and manage databases. So it is a software which is used for creating and managing the databases. DBMS users lets you to create a database, store, manage, update, modify, retrieve data from the database. These are the operations the users can apply with the help of a DBMS. First is to create a database, then is to put information into it, insert information, then manage that information, and depending upon the requirement we can update, modify or delete the information. And retrieval is also one of the important part of the database, like we perform in the form of queries. Some of the examples of open source and commercial database includes, like we have MySQL, that is the part of our syllabus also. Then Oracle is there, Postgres is there. Then we have Microsoft SQL Server, Microsoft Access, and MongoDB. So we basically categorize the databases into two categories: open source and commercial. And this is the broader category of databases, and this is just a few of the databases are listed here. This is a huge list because nowadays we are getting graphical databases, so a lot of new things are going on in this domain. This is an ever-changing domain and very vital. None of the organization can survive without a database. So a database is very crucial and important aspect for all the institutions. So again, depicting to the our main diagram. So here you see the database, and above that we have a RDBMS, that is a relational database management system. That basically software works on our database, fetches the information, stores the information, updates the information. And the first important aspects here you can see the designing part. Very crucial that a database design must be up to date, that it contains different tables and so on. DBA is basically the person who is overall responsible for the vital and 24/7 functioning of a database. So the DBA jobs are very highly paid, because you know that the working of database in a proper manner in a organization is very crucial for a organization. So if a database fails, so then the normal functioning of the organization will get affected. Then after DBA we have programmers who programs the database, and basically in different applications they use databases. They are like they are developing an application. So in that application they will use a different database. So programmer use the database very frequently, and then finally the implementer who are going to use these databases. So this picture depicts the basics of the database. Students are saying a bit more on the DBMS system itself. So a database system hides certain details about how data actually stored and maintained. Because you see that let's say a person is working in a bank, so he is dealing with the database, but he is not dealing with the technicalities of the database, how the database is to be designed, and how if it fails then how to recover it. He just uses the database. So in that scenario it provides users an abstract view of the data. So for a normal user the certain complexities are hidden. Like let's say we are using television. So when we are using television, so we don't know the technicalities, that how the picture will be displayed on the TV. What are the technical things? How the picture tube is there? What is the technology for developing the picture tube is there? And how the basically our dish DTH is accepting the signals from the satellite and so on. So we are not just we know the details of that TV and its telecast. We are just know that how to switch on the TV and just press the appropriate channel to get whatever. If we want to do DD News, or like we want to see Star Sports, or like a channel, we need to know just the channel number only. So the technicalities are hidden from a user. So the same thing is provided by a DBMS. So a database system has a set of programs through which user and other programs can access, modify, and retrieve that stored data. So a user in a bank can fetch the data for a customer by applying the appropriate query over there. So the interface is very helpful for those users to extract that information. Now students, here you can see the different applications of database in real life, like in a banking. So in a banking, database is used to maintain the customer information, account details of a person, his loan details, his transaction detail, when and which date he has performed a transaction. So all those details are stored inside it in a database. If we discuss the another application like crop loan, for a crop loan, like let's say we are storing here the information of the Kisan credit card data, then his personal data like his age and his personal location, address, phone number, and so on. Then the land area, how much the land that person is holding, cultivation data, loan history, how many loan he has already taken, and their repayment data. So like this information we are storing inside the database. Then we have the application in inventory management. Inventory management is what is basically stock management system. So like many of the organization, they work for store management, like where we are storing product details, customer information, order details, delivery data, and so on. So here we are managing our stocks, how many products are there in our godown, how many products we have sold, and how many are remaining, and at which date we have it basically to reorder for fresh stocks, like this. Then we have organizations resource management. So like the organizations are use the database for their employees records, their salary details, their department information, branch locations, and so on. Like for another application is online shopping, like Amazon, Flipkart. They store the information in database regarding the item description, user login details, user preferences details, that a customer is buying which sort of products from their site, and so on. So like there are numerous examples are there, like railways are there, airlines are there, schools are there, colleges are there. Each and every organization, they have a database with them. No organization can survive without a database. Then the key concepts in DBMS. So we will have a look at a few of the important concepts in DBMS. Like the first important concept is database schema. So database schema is what the structure of a database is. What a database basically contains, its design. So basically database schema is more related to the designing of the database. So database schema is a design of a database. It is the skeleton of a database which represents table names and fields. So a database schema contains number of tables and the data type of each column it hold, different constraints that we have applied on the columns, and the relationship among the tables. Like a database schema contains, let's say, 10 tables, and what is the relationship among different those tables. Database schema is also allowed the visual, is also called the visual and the logical architecture, as it tells us how data are organized in the database. So this gives you the overall structure of the database. So that is what we meant by the term database schema. So like here in this diagram you can see that this is a database of a school where teachers are using the database, and whatever this database is, first of all it will be structured, it will have some schema and design, clear, and then a teacher can apply a query, and with the help of this software it can fetch the data from the database and get the required results. Similarly, office staffs are also using the same, and later on you can see students can also use this database for getting their attendance, what is their attendance percentage, and like so on. So this is how basically a database works in an organization. So we have taken the example of a school. Moving next, the second important term is database constraints. So what are constraints basically? Constraints are the conditions. Like the schools lays the condition that for appearing in the final exam you must have minimum 75% of attendance. So what is this? This is a constraint. So similarly in database, sometimes we put constraints or restrictions or limitations on the type of data that can be inserted in one or more columns of the table. This is done by specifying one or more constraints on the columns where creating the tables. For example, one can define constraints, the column, like we are taking the example of a mobile number, and we say that the mobile number should exactly contain 10 digits, not 9, not 8, not 11. So like this sort of conditions we can apply. Similarly, we can apply a condition on a student that a student roll number should not have null value, means it should have some value. And all the roll number should be unique. Unique means that each student should have a different roll number. No two students in a class should have same roll number. And constraints are used to ensure accuracy and reliability. So why we apply the constraints on the database? Just to ensure accuracy as well as the reliability of the data. Then is another important term that is used with the database is metadata or data dictionary. So what is this? The database schema along with the various constraints on the data is stored in the database in a database catalog or dictionary. That catalog or dictionary is called metadata, that is called the data about the data. Like we have an index in our book. So that index basically tells that what my book is containing. So similarly, whatever the database constraints we have applied, whatever the table name is there, whatever the columns we have, the detail about those is basically the metadata. So then students, the final term that we will describe is database instance. So we can define a database structure or schema. The state of a database is empty. So initially what we have, when we define the database structure or schema, our database is initially it is empty. That means no data entry has been there inside our database. It is just having a structure only, nothing is there inside that structure. Like we can take of a home, that a unsold home is just a structure only, there is no one is residing inside. Clear? After loading the data, the state or snapshot of that database at any given time is called a database instance. We can give the example like, let's say a bank person is into a bank and some customer goes to the bank, and let's say at 9 o'clock he has deposited some money, at 11 o'clock he is withdrawing some money. Clear? So the instance of his database are changing, means before 9 o'clock the instance give a different view. After 9 o'clock when he have deposited the money, so the instance is different. When he is withdrawing the money, the instance is different. So we may retrieve the data through queries or manipulate data through updation, modification or deletion. Thus the state of database can change, and thus a database schema may have instances at different times. So instance means that at a particular point of time, what is the state of that very database is. So when the databases are getting updated, like let's say through a online shopping site like Amazon, we are buying something. So that when that transaction is holded, before that this instance of my database is different, but when the transaction is done, the instance will get a different view. So that is what a database instance is basically. So students, we have just today covered the basic terminology, what is DBMS is, and the different terminology like database schema, metadata, database instance, DBA. So we have just gone through the basic terms, and you must go through these terms from your textbook also and read them carefully. And if you have any doubt, we can discuss that in our coming lectures. So at the end of the lecture, I thank you all for attending this session. Thank you very much.